test it up if I go the right direction. Hey guys, this is Glenn from Wilton Innovations again. So we're back on the Wilton project. We finished the press up and the adapter plates. So we're going to finish up the one bracket for the Wilton plate. I have it modeled up here and programmed. I'm just going to show you that real quickly because in the past going through all the programming and the modeling really didn't add any value, so we're not going to bother doing that on current projects. So we're just going to show you what the final result looks like, and then we're going to start making the parts. But let me just show you what we're going to be doing and what the part ended up looking like, and then we'll go from there. All right. So just in case you forgot, this is the part that we're working with. So there were a couple changes that I made to it in the model from the last time you saw it. One thing that I forgot to do was there is, move this over a little bit, there was a little dip here, depth difference between this and this. That wasn't shown in the original 3D model I first showed you when I reverse engineered it. And I realized that once I went back and looked at the part that we had to put that in. So this is what the model looks like. This is what we're going to machine. These score marks here are just at 10 and 5 degree increments. One thing that I did add to this model that's not on the actual part is I added these two little through holes. These are going to be tapped holes for 1/4 20. And the reason I'm using those is that I want to use standard 1-inch bar stock for this thickness right here. And this is just about 975, the total thickness of this piece. So I don't want to go up in bar stock size, so I'm going to use 1 inch. But in order to use 1 inch and get around this whole contour here and run this profile, I'm actually going to be bolting this to a fixture plate, and then I'm going to do all the machining. So that's what I'm going to use these tapped holes for. And just real quickly, this hair's nest of a program here, this is actually the program that we're going to be running. These are all just the tool paths. This is actually Mastercam. So I just wanted to show you that real quickly. So basically we're going to be doing all this contouring around the outside. Let me turn those off. All the contouring around the outside, pocketing out this inside, and then we'll flip it up on its side and put in these holes here for the clearance bolts. So let's go out to the lab real quick, and I'm just going to show you something I typically do with reverse engineered parts if I can. And then we'll go back to the shop and get this thing started. Alright guys, so we're back here in the lab, and a lot of times with reverse engineering projects, what I like to do is I like to, if I can, on either 11 by 17 or even bigger, this is 8.5 by 11 piece of paper, I like to print out the part that I reverse engineered in full scale, and then take the parts, this is a sanity check, and just kind of do a fit check and a check just to see how close things look, because sometimes when you do digitizing, you might digitize or comp to the wrong direction and things like that. So so this is a printout of the solid model, and you can see that basically this is our part, our front piece here, and you can see we're a little shorter on the ends than this actual piece. The reason is again, we're machining this part, so we needed some clearance over here for 1/2-inch end mills and to allow us to get conventional tooling in there. So this ends up being a little shorter, but it's not going to affect anything we're doing. So I flip that around, and then this is the other piece that sits in the top here. And again, this is just to check the arc, and you could see, or maybe you can't, but I'll lie to you and tell you. The arc matches really well, so we know we got the right radius. And again, because we're actually digitizing points along this surface here, you know, I like to just do some sanity check to make sure that we're getting the right features. But it looks really good, so I'm happy with that. And I did this before I actually finished the model and programmed it. You know, otherwise I'd be wasting a lot of time. So, but I just wanted to show you that you know, we do that quite a bit. I will print things out full scale and do a sanity check. So let's get back into the shop. We're going to put this probably on the Kiwa today. I'm going to run it with single tooling. I'm not going to use the tool changer, so we'll be touching off each tool individually, which for a project like this, that doesn't bother me. So let's get to the back and get that started. One thing I do have here is, this is the material that we're going to be using. It's basically a 1-inch stock. Like I said, the reason I'm bolting this plate down to a surface plate is because I want to stay with 1-inch stock, so I don't have to go any thicker. These are the two 6-inch sections we're going to use. So basically, that's the size that we're going to be running in there. So there's a little bit of clearance on each side for the tool to go around and clean up, and that should work fine for us. I really only needed like 3-inch stock, but I had some 3-inch bar stock on the shelf back there, so I figured I will use that instead of ordering new stock. So let's get the back, get it cut up, and then we'll get it on the Kiwa. Okay guys, so we're out on the shop floor. A couple things here. So these are the two blocks we're going to use to make the brackets. This is the print I put together. I don't know how well you can see that, but the only thing I care about is, since a lot of this programming is going to be done, or the machine is going to be done with the program I created, I don't put a lot of dimensions on the drawing for my particular purposes. If it's a production part and we have to inspect it, that's different, but again, for internal stuff, I just put some features on here that are important to me. And since we're adding these additional holes here to tap them for 1/4-20 screws, I have to make a fixture block to hold those, so I can screw in from the bottom, hold this plate down, make sure the threads don't come up through there, but I get enough thread engagement to hold this in place while we're machining around it. So what we do a lot here in the shop is we have a whole box, I'm pointing over there, but over there, we have a lot of old blocks that were either parts that when we were machining them didn't come out the way we wanted, or who knows what. But so we keep them around for fixture blocks, and you'll see like this one has a lot of different contours cut into it, pockets in the back, and there's a lot of different screw holes in here. So what we typically do is, if we can find a part that'll fit on there, and if I grab this part that we're going to be making, basically this is pretty much the size that's going to be on there, and through here there are going to be a couple through holes. So this block will hold this piece nicely for what we're doing. But since it's been machined a couple times with a couple different types of contours, I'm just going to put it on the machine, fly cut it down a bit to give me a nice surface to work off with. And then, like I said, this is thick, so we'll keep machining these down and down and down until we can't use them anymore, and then we'll just throw them in the scrap bin. But as opposed to just throwing them away, we end up using them for fixture blocks and holding them. So what I'm going to do now is just transfer these hole locations here for the 1/4-20s to this block here as through holes for the 1/4-20s, so we can screw up through the bottom of this plate, hold this piece in place, and then do our contouring machining around it. So I'm going to get it set up here in the machine, and then we'll do some fly cutting. Okay guys, so we're at the machine we're going to be using. This is a Kiwa Code 510. We have two of these here in the shop, and I like using these machines quite a bit. Not that I don't like the Haas, I love the Haas machines, but these are older machines. They're, I think, 1993, 94 machines, the ones we have in here in the shop. They're extremely accurate machines, and they're extremely heavy duty, which is why we keep them and had them for so long. One thing about these machines is that the controller on it's still a standard old style FANUC style controller. It doesn't have a lot of memory in it, which becomes a limitation sometimes for this machine. So you can't load a lot of programs, and even the one we're cutting, since this only has like 16K of memory, yeah, 16K of memory, you heard me right. A lot of times we have to break the programs down into smaller bytes, or we can drip feed it from the computer. But a lot of times we have clever ways of breaking them down and not having it impact the way we run the parts. So that's what we're going to do on this machine. But one thing I like about these machines, even though it has a tool changer, this machine is very easy to run in manual mode, basically just touching off all the tools and running them as if you run them on a Bridgeport or a track machine or something like that. So that's very convenient, and that's why I like running them. So I'm just going to show you what we have in the machine here, and then we'll get this thing cutting. So here's the block. There's the other Kiwa over there, just in case you're curious. And that's the Haas. And that's the Akuma. We got a bunch of machines in this shop, all packed in here pretty tightly. But, so here's the part, the block I was just showing you. We're just going to fly cut this off, get it to size, and then we'll get it set up, get some holes drilled in it, and do some tapping. We're actually not tapping on this, we're going to clearance holes on these, but get it all set up, put a stop in there so we can take it in and out of the machine and not lose its position. So we're just going to get that going and fly cut that up. Okay guys, so I fly cut both sides of this block because when I put it in on the bottom side, it was still wiggling quite a bit on the parallels. So I didn't like that very much. So I took a skim cut off of the back side and then set that on the parallel, pounded it down. So this is the block we're going to be using. I'm going to put some clearance holes in here for 1/4-20s. I did set a stop over here. Originally I had one of these edge stops set up, but the problem is that because this piece that we're machining actually is bigger than the plate, that means that the raw stock we're using is actually bigger than the plate, and therefore I couldn't actually put an edge stop up there without this block hitting it. So I just put a standard clamp style edge finder here with a locking arm. So basically that hits the side of this plate. So when I take this in and out now, I can bring it up against this block here, or against this pin, and that'll locate my block again. And remember, since we're coming up through the bottom of this with some 1/4-20 screws to hold our raw stock in place, I have to take this block in and out and then put it back in to machine the second piece. So that's why I put the stop there. So what I'm going to do now is basically I got to put the holes in, the clearance holes, and I was debating on where I wanted to put them. And basically what I'm going to do is, since I'm coming off, I have this outline here, which is my 3.5-inch piece by 6-inch long block that I'm starting with, and all my dimensions I pulled off the corner of my block. So for all intents and purposes, what I'm going to do is I'm going to edge find off of this side and off the front of this, and then move over my 1.5 and then 4.5-inch dimensions, and then 1-inch 060 up from that bottom face. And that'll give me a good location of where these holes are going to go in the block. So when I put the raw stock back in, basically I'm just going to line it up on the edge of the block here. So I need to put tapped holes in this block in order to hold it. So I'm going to edge find off of these two when I do that, and then I'm just going to shift them in like 30 thou in each direction. So that'll move my holes into the block a little more. So when I do fasten it to the block, it'll actually shift it off to the left here a little bit, so I make sure I do have clearance all the way around, and I clean up all the outside edges of this. So that's all I'm going to do now is edge find this block in, and then put the clearance holes in for the 1/4-20s, and then we'll put this block in, and then the other blank in, we'll drill them and tap them for some 1/4-20s. So that's what we're going to do now. Alright guys, so we got the clearance holes in here. I'm just going to switch out the drill, switch out the block, put the piece of raw stock in here, drill it for it and tap it for a 1/4 20. I put a little indicating mark up here near this through hole, so I know which side of the block I'm actually indicating off of for those holes, so I don't get them confused. So I'm going to switch this block out and then we'll start tapping the raw stock. Hey guys, before I put those holes in, this bar stock up on the rack was pretty ragged. So I'm going to take a fly cut on each side of this, on each piece, just to clean it up a bit before we actually put the holes in there. Because one of the sides is actually going to be our finished side. We're not going to do any more work to it. Then the other side we're going to fly cut down just a little bit to bring it the size. But so I'm just going to do that now. I'm just going to fly cut this just so we have it the size. Okay guys, so we got both sides fly cut up and squared away. So I've got the tap drill size for a 1/4 20. I had to do a little bit of the math here because hindsight being 20/20, I would have done a little differently. But when I set this up initially, I called this my rough stock here, which was a 3.5 inch piece of bar stock I have in the vise right now. But I pulled it off of this point here, and this point here is my non-fixed jaw on the vise. So when I threw my 3.5 inch piece in here to put my put my 1/4 inch 20 tapped holes in, the distance from my floating jaw to my fixed jaw changed, but the plate that I had in there, which was only a 3-inch plate, this position here is where I came off of to get my clearance holes. Upside down. This face here is where I came off to get my clearance holes. So as you can see, it's a 1/2 inch shorter from here to here. So I had to adjust all my numbers up on my print here to figure out where it would be, which is basically the 1/2 inch difference between the blocks, where the holes should be in order to make sure that this piece sits inside of my raw stock. So when I cut around it, I get cleanup on all the sides. So we had to do a little bit of math before I got started. So now I'm just going to put the clearance holes in for the 1/4 20. I'm going straight through the block because this is going to be my bottom side. This is the side that this is actually my top side. This is the side on some of the blocks that didn't clean up as nicely because the blocks had a little bit of cup in them. So I'm going to get rid of all of this when I do the contour. So I put my good side down, but because my good side is down, I have to tap all the way through because I'm actually going to be screwing up into my good side to do the machining. So yeah, that's about it. So I'm just going to tap these or drill these straight through and then tap them from the other side, and I think we'll be good to go. And the more I think about that, that's not right, because actually this is my bad side. So now actually I'm going to leave the good side down because I don't want to finish that side when we're done. I want that side already to be done into size. So yeah, we're going to leave that the way it is, and yeah, we're just going to drill and tap them. Okay guys, so this is what we got. These are the holes with the tap drill holes. I'm going to take them over to the bench, just hand tap them. So basically, the way this is going to work is these are the holes that are coming through the block. So these are the clearance holes. So basically, the socketed cap screw is going to come up through these holes. We're going to bolt this plate down through the bottom, through these tapped holes here, and then we'll do all our machining and contouring. And like I said, I don't know if you can see it, but some of these blocks didn't clean up that nice. So on the edges over here, there's still some of the raw material scale, which is why I put the bottom side down, because I'm going to leave this side, and then this side, when we do all of our contouring, all this scale will be cut out, and this won't be sitting on a parallel. This is a nice true surface that'll be sitting on the parallel, so we know we'll get nice and flat. So I'm just going to take it over to the vise over there, hand tap these real quick, and then bring them back in and then show you what we're going to do with the socketed cap screws and the rest of it. Okay guys, let me show you what we got here. So I finished tapping these holes, and this is the bottom of the plate. So basically we're going to flip this over and screw it down. I have a couple screws here. This is the plate we're going to use, and I guess this is the downfall, not really a downfall, but this is the challenge of when you use reuse fixture blocks. These two holes that I drilled through for clearance for the quarter 20s, on the back side, one comes through on the plane of the surface, the other one comes through in this pocket that was in there for another operation. So when I bring the clearance screws through, the furthest that these screws can come out of this plate, because the thickness of this web that's left over after machining is about 200 thousandths. So I want to keep this thread engaged in this material about 150 thou and no more than that. So when I'm milling out the pockets, the end mills don't hit it. But that becomes a little bit of a challenge because of the thickness of the block and the availability of the screws. So you can see one of them I had to actually put a countersink in for the longer screw, so it just comes out of the surface with a couple threads. I don't know if you can see that or not, but just a few threads there to actually pick up the block. And then on the other side, we've got the smaller socket of the cap screw that comes through. Again, just enough threads to actually capture the block. So when we actually put this block onto the fixture plate and screw it down, you know, it's actually holding the block in, and that's all it's going to hold when we're doing the machining. I mean, it's got about, you know, 2.5 threads on each of the screws, so that should be more than suffice. I mean, we're not going crazy hogging all kinds of material out of this. So we'll see what happens. So right now we're going to get the machine set up and yeah, start whittling these things. Oh, that's annoying. Start whittling these things away. All right, see you in a bit. So real quickly before we start running it, this is kind of what I meant when I said I had to run multiple programs. So this program here, it's a bunch of pocket and contour. It's about 68K of memory, which is not a lot. But this machine I have right here is only about 30K available on the controller I have. So as you can see here, this is kind of what I was talking about. So I've got a Wilton bracket top, and I got it broken down into 1, 2, 3 different operations, because when I post this program, which is the first operation we're going to run, all the operations are using the same 1/2-inch end mill, but I had to break them into segments, because if I posted this all as one program with all of its operations, it was bigger than what the controller could actually hold. So again, one of the limitations of the Kiwa, you know, we looked at actually upgrading the memory, but it was like $4 grand for an extra 32K. It was ridiculous. So we decided not to do that. Like I said, it's not really a problem. I just figured I'd show you what I was talking about. All right, let's go to the machine. Okay, so we're at the Kiwa. And one, like I mentioned earlier, I like to use this machine and touch off each tool when I'm just running without the tool changer. So you can see in every program I'm going to run, my H0, which is my offset, my tool height offset, is going to be 0 for every single one of them, only because in this machine the first available offset is 1. So if I use 0, it doesn't call any offset for me. So that works out really nice for me. And then instead of actually, in this line typically would be the tool change, I just get rid of the tool change call out and just do a commented line. This just tells me what's going to run, and that allows me to actually run it in manual mode, and I can just touch it off like I do Bridgeports, and then I can record the offset of a tool, so when I run the next piece, I can just bring it down to that Z position, zero it out there, and then run it. So what we're going to do now is, I have the 1/2-inch end mill in the machine, and now this is all bolted in, the plate's in there, it's up against the stop. I've got my black mark up against the stop, the way that I ran this, so I have these holes in the right position. It's bolted down to the block. There's about 125 thou between the vice jaw and the top of the fixture block that we're running it on. I didn't indicate the same because I really don't care, because my part's going to sit inside this block, so all this material is going to be cut away. So we're just going to touch off this tool and get it ready to go. So I'm going to get that set up, and then we'll touch it off and let it run. Alright, so there's op 1. Op 1 meaning that that's the first program I loaded. I had to slow the feed down quite a bit because those 2 screws, because there's still clearance in the holes. You see in that earlier operation where it actually moved a little bit, so I had to slow it down, which is why we had to run it so slow. So I'm going to load the next program, and that's going to put the pocket in here, pocket this down to depth, and then we'll start putting the chamfers on there, and then this one will actually be done and ready to go. So I'm going to get the other program loaded, and away we go. Okay, that's the second op. This is where it was clearing out this area here for the end mill. You can see maybe you can see, the heads of the screws that come through. They're down about another 30-40 thousandths, so the end mill never hit those. Ran the profile around, cornered the edges. So now we're just going to go and chamfer all these edges. And I believe that's it. And then this side will be done. Then we can flip it over, do this side. Skim and cut the back side for the material that's left over, and then this piece will be done. Let's get to it. Okay, so this is the last program we just loaded. So this is the chamfer mill. It's going to go run and do the chamfering just to break the edges. Then we got the big chamfer mill, the 3/4 and 60 degree, which is going to put that relief in there that actually is the lock for the slide. And then I got the center drill in here, which is really an engraving tool, which is going to put those little hash marks in for the actual degrees. So this is the first tool we're going to touch off. That's just a regular 45 degree carbide chamfering tool, and it'll go around, it'll break all these edges, it'll break these edges and just put a nice break edge on them, and then we'll continue on. Let's do it. Okay, here's that 60 degree chamfering tool. So basically that's going to put the inside chamfer on here for the lock. It's pretty aggressive cutting tool, so we're going to take it slow, see how it does. Alright, let's get it set up. This is our last tool for this side. This is just a number 3 or number 2 center drill. On aluminum they actually engrave pretty well, so that's what we're going to engrave the marks on this face with right here. Is that center drill, so we're going to just get that touched off. And like I said, just a regular center drill. Nothing real special about it. You might be able to see a little better from there with the backdrop, but that's all it is. Alright, let's get it set up and ready to go. So we finished this piece. Here it is. So let's get this thing unbolted and see what it looks like. Looks like it came out pretty good. A couple little things that we're going to change on the second one when we start that. Nothing really big, just some of the speeds and feeds. But for the most part, ran really well. Nothing really complicated. So coolant still left all over it. Alright, so there it is. Let me bring it over here a little bit. So, I bring the camera this way. Unbolt this thing. Alright, so here it is. Actually came out pretty good. The numbering up here, I don't know if you could see it that well, actually came out pretty good. All the chamfers blended really nicely. You can kind of see, well, you more than kind of see. You can see that the chamfer in here, that's going to be the lock. Again, we just used the standard 60-degree chamfering tool for that. It worked out pretty well. The threaded holes in here, we might actually use for something later to actually hold a protractor style device that I was thinking about making for this, instead of actually using these numbers. But these numbers, we'll color them with some paint, and at least we'll have 10 and 5-degree increments. So I mean, everything, you know, blended really nicely. Nothing really major here. A couple burrs we just got to blend off. But so we'll get it set up next on the base side here, just to put these holes in. That's kind of a no-brainer. And then this back side here, it's probably a little oversized right now. I'm not going to worry about it because this doesn't locate on anything, so it's not going to affect anything. But for the most part, yeah, came out really nice. We'll probably send it out and get it anodized, I'm thinking. At least that's my thought right now. But that's it for now. I'm going to get this set up back in the machine to do this base side here, and then we'll get that done, get the yellow on there, and then we're going to go back to these and start figuring out how we're actually going to make these pieces, because this piece here and this piece here, which is the broken piece, which is going to mate with this piece here at some point. So but we still got to figure that out. Like I said, this one's going to be a little bit more challenging to work with, just because it's a deeper countersink in there, or a deeper groove trough. So we'll have to figure out something for that. But until then, let's finish up this base piece here, and then we'll get on to the other piece.